In this video, we're going to look at what we're going to token for now, the reverse chain rule. And the idea or the hope is that by the end of this, our objective is to be able to integrate something like this problem right here. And it looks pretty challenging, but we'll see pretty quickly that these types of problems are very, 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 very doable. So let's start off though with the chain rule and the derivative. So we know that the derivative of the chain rule, as hopefully this is fresh in your head, but the derivative of a chain rule is the derivative of the outside function, so f prime of g of x times the derivative of the inside, g prime of x. So, if the derivative of f of g of x is this, what would be the antiderivative or the integral of f prime of g of x times g prime of x? Well, the derivative of this is that. So the antiderivative of my integral here should be just f of g of x. And then plus c. Okay, so what is that? What is this going to look like in practice? The idea is we're going to need to, when we get these long integrals, we're going to need to identify what is my g of x function and what is my f prime function. So let's take a look at an example of that. So let's say that we wanted to integrate cosine of x squared plus 1 times 2x dx. Okay, and so this is going to be a reverse chain rule, and what we need to do is identify what is our f prime of x, what is g of x, and what is g prime of x. Because if we can do that, going back to the, well, no, we don't need to go back. If we're integrating f prime of g of x times g prime of x dx, what we get back is just f of g of x. Okay, so this is our first go at it. So let's think about it. We've got cos of something times something. Well, this inside function looks like to be it's probably the g of x, and it is. It's our inside function. It's a composite function. So this is the inner function. So g of x is x squared plus 1. And then we've got the 2x. Well, that's the derivative of x squared plus 1. And so then our outer function is cos. Well, now we need to find f. So if f prime of x is cosine x, then f of x equals sine of x. That's the sine of x is the antiderivative of cosine x. So now I have f of x and g of x, and I've got this antiderivative that's a reverse chain rule. So this is going to equal f of g of x, sine of x squared plus 1 plus c. And that's exactly, if you were to take the derivative of this, you're going to get this back. And so the key here, the tricky part is to identify what is the outer function. In this case, it was cosine, and that outer function is our f prime. And then what's our inner function? And that's our g of x, so x squared plus 1. And then it's going to be it'll always be being multiplied with g prime of x. So, if here's my inner, that value is always going to be the derivative. Let's look at a handful more of these problems, because just exposure will make things click. So example 2, let's imagine that we're taking the integral of the square root of, let's say, 3x to the fourth plus 2 times 12x cubed dx. Okay, so let's go ahead and try to identify our function. So our f prime of x, I think the easiest thing to identify is the inner function g of x. And in this case, our inner function, we'll try to figure out what you think it is. Here is our inner function right here. Our inner function is 3x to the fourth plus 2, and the derivative of that is 12x cubed, and that we see right here. So what would be my, our outer function, which is f prime of x? Well, my outer function, is the square root of something, so it's just the square root of x. So therefore, what would be f of x? What's the antiderivative of root x, or written slightly simpler way, x to the 1/2? Well, that's going to be x to the 3/2, and then we have to multiply by 2/3. So because this is falling into the reverse chain rule, I know that this is going to equal f of g of x. So it'll equal 2/3. And I'll put g of x into x. So 2/3 times 3x to the fourth plus 2, all raised to the 3/2 plus c. All right, hopefully you're starting to see this pattern. So in the next example, pause the video and see if you can do it. Now, it is a slightly more challenging problem, potentially, but let's see how you do. So we have sine squared x times cosine x dx. And before you pause the video, I'm going to make the suggestion that whenever you see like the trig functions being squared or cubed or whatever power they're being raised to, I think it can make things a lot more visible if you write it as sine of x squared times cos of x. Okay, so pause the video and see if you can get to the right answer. All right, so I think we can identify g of x. G of x is our inner function, and it looks to me like the inner function is going to be sine of x. So g of x is sine of x. And we know that the derivative of that, of sine x, is cosine x. And here's our cosine x. And so what would be our outer function? Well, our outer function is something squared, so x squared. And if that's our outer function, if f prime of x, our outer function, is x squared, then what must be f of x? Well, f of x, taking the antiderivative of that, is going to be x cubed, and then we need to put a 1/3 out in front. So this antiderivative, this definite integral, is f of g of x. So it's 1/3 of g of x cubed. Okay, so let's look at one more or a couple more examples. But in the next examples, the derivative of g of x is off by a constant. What do I mean here? So let's look at an example. So we've got, let's say we've got the integral of e to the 5x squared times 2x dx. All right, so slightly harder problem here maybe. And let's talk through this. So we've got e to the 5x squared. So e to the something, and maybe it's helpful to write parentheses. To me, that makes it more clear that our inner function is 5x squared. So our derivative function, or the derivative of g function, is going to be 10x. Uh-oh, I only see 2x here. And I want g prime of x should be 2x before they've all worked perfectly. So what do I need to do? Well, I need to multiply this by 5. So what I do is I'm just going to multiply the inside by 5, but I can't change it. So on the outside, I'm going to multiply it by 1 over 5. So then what we get is 1 over 5 times the integral of e to the 5x squared. And let's multiply the 5 and the 2 together, times 10x. So now it's as I would like it to be. Okay, and what would be the inner function, or sorry, what would be the outer function, in this case, f prime of x? Well, f prime of x, we've got e raised to the something. So our outer function is e to the x. And the derivative of, or sorry, the antiderivative of e to the x, we know is e to the x. So we've got, now this is falling into the, this is falling into our pattern, which we've now spent some time looking at. And the pattern that we have is that it is the integral of f prime of g of x times g prime of x dx. Of course, in this case, there's a constant out in front. So just like before, our solution is f of g of x. So here's f of x, here's g of x. So our solution is 1/5 e to the 5x squared plus c. So here is my definite integral, or my indefinite integral, which is the same thing as the antiderivative. Okay, we're going to look at a couple more examples, and this one's a fun and tricky one for us to consider. So let's imagine we've got the integral, wrong pen, the integral of 2 plus cosine of 3x squared times sine of 3x. Yes, dx. Okay, well, what do we want to call the inner function? Let's call, I think it makes sense that this is our inner function. So g of x equals 2 plus cosine of 3x. And the derivative of that, g prime of x, well, the derivative of cosine is negative sine of 3x. And then times the inside of that, which is times 3. Okay, so what are we missing? Our g prime here is just sine of 3x. I don't have the negative or the 3. So we just throw negative 3 there and multiply by negative 1/3. So we're not changing its value. Negative 1/3 times negative 3 would get me 1 back. But what that allows me to do is write it as negative 1/3 times the integral yeah, so now it's very clear that I've got the g prime of x. I'm just moving. This is times negative sine of 3x times 3. So I just move that negative 3 down here. So it would look more like my g prime of x. And let's see, our f of x, or rather f prime of x, is is something squared, so it's x squared, and so the antiderivative of that would be 1/3 x cubed. All right, so now everything is fitting into our our reverse chain rule. So we get -1/3, that's the constant out in front, times f of g of x. So times 1/3. Here's my g of x. So 2 plus cos of 3x cubed plus c. All right, so this is about as hard as it will get for now. The other type of problem that we need to look at, though, is when we have quotient. And before we get into the integral, let's think about what is the derivative of ln of e to the x plus sine x. Well, this is a chain rule. So the derivative of this, the derivative of ln of something is 1 over that something. And then times the derivative of the something. And the derivative of that something is e to the x plus cosine x. Okay, this should bring up the general form that if anytime you're taking the derivative of ln of a function, you will get the derivative function over the function. So therefore, let's say that we wanted to integrate f prime of x over f of x. So anytime we have the derivative function over the function itself, this equals ln of, absolute value of f of x plus c. So let's look at two examples of that. We've got let's say we have the integral of, let's say 5x to the fourth plus tan x over 20x cubed plus secant squared x. So we need to just check, is this following that pattern? So we look at the bottom, and let's call the bottom f of x. So f of x is the denominator. And then let's take the derivative of that. Well, the derivative of 5x to the fourth is 20x cubed. And the derivative of tangent, we know, is secant squared x. So this is, in fact, falling into that pattern. So because the numerator is the derivative of the denominator, we can express this indefinite integral as ln of 5x to the fourth plus tangent x plus c. And let's finish with one example where the top isn't exactly the same. So let's think about the integral of sine of 4x cubed. No, let's not. Yeah, plus 12x. And the top is 6x squared plus 6. Okay, so no. All right, sorry about that. Here's the problem that we're looking at, and what I'd like you to do is try to do this one on your own. So pause the video, see if you can get an answer. You're gonna have to combine what we just learned and then what we learned a little bit previous to that, but you have the skills to do this. So pause the video and then see if you can get the solution. All right, so let's look at the bottom. The bottom f of x is 4x cubed plus 12x. So we want to see if this fits into the ln pattern. And the derivative of that is 12x squared plus 12. Well, that's not our numerator. But what I could do is if I multiplied my numerator by 2, then we'd get 12x squared plus 12, which is what I have here. But if I'm going to multiply it by 2, I have to multiply by 1/2 on the outside. So therefore, I get 1/2 the integral of 12x squared plus 12 all over 4x cubed plus 12x dx. So this indefinite integral is 1/2 times ln of the absolute value of 4x cubed plus 12x. And then always, always, always plus c. All right, so that's the reverse chain rule. This is always a little bit challenging for students, but I think maybe go back and watch this again. Take some time to practice it, and I think you'll be all set.